In the last section, that was section 5.3, we talked about calculating probabilities for independent events with the multiplication rule. Now we're going to talk about something called conditional probability, which is how we calculate probabilities for dependent events. So, what is conditional probability? Conditional probability is the probability that event F occurs when we know that event E has already occurred. And remember, dependent events means the outcome of one trial affects the outcome of additional trials. So the notation we use is the probability, in this case of F, and then we use a vertical line and E. And we read that as the probability of F given E. And this given E stands for the when we know that E has already occurred. So conditional probability means that we limit the number of outcomes from the whole sample to the number of outcomes in the event that is given. So the conditional probability rule says the probability of F given E is the probability of F and E divided by the probability of E. So let's see what that means. So for example here, in number 4, we have a table showing the American adult social media usage to find, and we're going to use that to find some probabilities. So we have, let's see, it's based on age group and whether or not they use social media. So what's the probability that a randomly selected adult does not use social media, given that the person is 35 to 44 years of age? So we have the probability of no, I'm going to use SM for social media, given the person is 35 to 44. Well, based on our rule, that's the probability of no social media and being 35 to 44 divided by the probability of being 35 to 44. So the probability of not using social media and being 35 to 44 is we look at the 35 to 44-year-olds and see how many of them do not use social media. That's 36. So we have 36 out of 530 total people, and we're going to divide that by the probability that someone is 35 to 44, which is, I will highlight this in blue. So and sorry, I should not have highlighted the P there. I should have just highlighted the categories. So the probability of being 35 to 44 is the number of 35 to 44-year-olds divided by the total number of people. So when we type this in the calculator, we are going to type it in like this. Let me move this up a little so I can see what we have. Okay, so we're going to put each of those two fractions in parentheses. So we start a parentheses and we do 36 divided by 530. And then we divide that by 125 divided by 530. And so we get 0.288. Now, hopefully you learned about dividing fractions in your other math class. So if we don't use the calculator, we have 36 over 530 divided by this other fraction. And when we divide two fractions, we keep the fraction up top the same. We change the division to a multiplication, and we flip the other fraction over. Every time we do a conditional probability, the total sample size is going to cross each other out, cancel each other out. And we're left with just the number in the yellow category divided by the number of the given category. So you can see the 125 came from the given event because we already knew that the person had to be between 35 and 44. And the 36 just comes from the number of people that are in both categories of 35 to 44 and not using social media. So that makes the math a little bit easier. And that's also what I was talking about up here when it says that conditional probability means we limit the number of outcomes from the whole sample to the number of outcomes in the event given. So let's try another example. I'm going to erase our highlighters from the table so we can concentrate on what happens this next one. Okay, so next we have what is the probability that a randomly selected adult who does not use social media is 35 to 44. This wording is a little bit different than the wording of the previous problem. If you can see, the first time the adult does not use social media given that they're 35 to 44. This time, where it says the adult who does not use social media, that means that this is the given event. And we want to know what the probability is that they're in that age category if we already know that they do not use social media. So we have the probability of being 35 to 44 given that they do not use social media. So, using our shortcut method, we are going to take the number of people that are both 35 to 44 and don't use social media. And we're going to divide that by the number of people who don't use social media. So the number of people that are both 35 and do not use social media. So we look at do not use social media and the total number of people that are 35 to 44. So that's 36 again. But this time our denominator is going to be the total number of people who do not use social media. So our denominator is going to be 192. And if we put that in the calculator, we have 36 divided by 192. And if we round to 3 decimal places, we have 0.188. So 0.188. So you see, even though the numerator is the same both times, our denominators are different depending on what the given category is. Okay, let's see if I can answer this question. Are adults who are 35 to 44 years of age more or less likely to not use social media than people in general? So we need to compare the answer from A to the probability that people in general, so no age categories, do not use social media. So the probability of no social media is, if we go back up here, let's erase our numbers. So not using social media, there are 192 total people that we surveyed that do not use social media out of 530 total people. So 192 over 530. And if you plug that into the calculator, you get approximately 0.362. So our answer from A was 0.288. And unfortunately, I'm out of time, so I'll pick up this problem in the next video. I thought I could sneak it in.